Theory on the Origin of the Universe. Part 1. What is the Big Bang Theory? What is the Big Bang Theory? The Big Bang Theory is a theory on the origin of the universe where the universe is said to have started from a ball of energy the size of grapefruit and then exploded in fractions of a second to expand billions of years to what is the universe today. Theories of the origin of the universe and how did the Big Bang came about. In ancient Greece, people believed that the earth is the center of their world and everything moves around it as they can observe the sun moving in the sky in the daytime or the moon moving at night. This was later called the Ptolemaic system. In the 15th century, Nicholas Copernicus had proven that the earth and the other planets orbit the sun. This was called the Copernican system. In the beginning of the 20th century, astronomers were not sure of the size of the world. In 1916, Harlow Shapley, an American astronomer studying a globular cluster, which is a group of hundreds of thousands of stars, in our galaxy, noticed the faint blue stars. He reasoned that if they are similar to those faint blue stars near our sun, then those faint blue stars must be very far to explain their lightness in color. In order to establish distances conclusively, he based his measurement using the Cepheid, a type of variable star. Shapley was finally able to place correctly our sun not in the center of our galaxy but on its outskirt. However, at the same time, he held a view that our galaxy was the entire universe. In the early 20th century, the common worldview was that the universe was static. In 1912, Vesto Slipher, an American astronomer, obtained a spectrogram for the Andromeda galaxy indicating that the galaxy was approaching our Milky Way galaxy at an amazing speed. Slipher measured the velocities of other spiral galaxies over the next 2 years. His first few measurements showed approaching galaxies on the south side of our galaxy, while on the opposite side the galaxies are receding. The result made Slipher formed a drift hypothesis whereby he thought that it was our galaxy that was moving towards the south galaxies, away from the north galaxies. However, his hypothesis was contradicted by the observations of more spiral galaxies, as receding spiral galaxies were found on the south side as well as on the north side of our galaxy. Nevertheless, Slipher clung to his drift hypothesis. By 1921, De Sitter knew of Slipher's measurements of the velocities for the spiral galaxies where the measurements showed only 3 were approaching. The observation of the 3 corresponding spirals was filed as the result of large velocities in random directions, superimposed on a much systemic recession. In 1917, Willem de Sitter, a Dutch astronomer, produced an equation that described a universe that was expanding. Einstein, taking the universe as a whole, used his gravitational field equations to provide just a compact mathematical tool that could describe the general configuration of matter and space. Einstein and de Sitter were in communication comparing their separate models of cosmology. Willem de Sitter's model could only be stable if it has no matter. Einstein's early model, on the other hand, could not contain matter and be stable. His equations showed that if the universe were static at the start, the gravitational attraction of the matter would make it collapse on itself. Einstein solved the instability of his model by adding a constant term to his equations. This constant, if not zero, would make his model not collapse under its own gravity. Called cosmological constant, Einstein admitted that it is only a hypothetical term and it is not required by the theory. The cosmological constant was only necessary for the purpose of making possible a quasi-static distribution of matter. Meanwhile, de Sitter's model of an expanding universe produced a diminishing frequency of light with increasing distance. In 1922, Alexander Friedman, a Russian meteorologist and mathematician, published a set of mathematical solutions that showed a non-static universe. In 1928, Edwin Hubble, an American astronomer, attended a meeting of the International Astronomical Union held in Holland where he discussed cosmology with de Sitter. Hubble returned to his Mount Wilson observatory to test de Sitter's theory of shifting frequency. Hubble with his assistant Milton Humason was looking for a displacement of lines in the spectrum towards the red, in what would later be called the red shift. What they both found was that the greater the receding velocity of a galaxy is, the farther the distance to it. Einstein agreed that the universe is indeed not static. Back in 1927, Georges Lemaitre, a Belgian astrophysicist and a Catholic priest, published his model of an expanding universe in a little read Annals of the Brussels Scientific Society. His paper was easily overlooked. When Lemaitre saw a report of the Royal Astronomical Society meeting held in 1930, he wrote to Arthur Eddington, who was his former teacher, reminding him of his 1927 paper. Eddington recognized the value of Lemaitre's paper and shared Lemaitre's paper to Dicke. Dicke wrote to Shapley. Note that Eddington also played the part in the acceptance of Einstein's theory of general relativity with his observation of the solar eclipse in 1919, where he observed that gravity could bend the light. Einstein confirmed that Lemaitre's work fits well into his theory of general relativity. In 1931, Dicke proclaimed in public Lemaitre's brilliant discovery of the expanding universe. The Big Bang theory of the origin of the universe is not the only theory. Dueling with the Big Bang theory is the theory called the steady-state theory. In the 1920s, Sir James Jeans was first to conjecture of a steady-state cosmology. He based his hypothesis on a continuous creation of matter in the universe. In 1948, Fred Hoyle, Thomas Gold, Hermann Bondi, and others, revised the idea of steady-state cosmology. The steady-state theory asserts that the universe has always expanded at a uniform rate, with no beginning or end, that it will continue to expand and have constant density, and that the distribution of the old and new objects in the universe is basically even. In order to have constant density, matter is created to fill the void left by the galaxies that are receding from each other. In a radio broadcast program, Hoyle coined the term Big Bang as an argument against Lemaitre's theory that described how the universe was created in an instant. In a 1948 paper, George Gamow argued that the Big Bang universe would be at first dominated by radiation. As the radiation expanded, it would be created into matter. Ralph Alpher and Robert Herman predicted that a remnant of the radiation would remain, a cosmic background radiation permeating all space. In 1963, Arno Penzias and Robert Wilson, working for Bell Telephone Laboratory while studying the sky's microwave noise, realized that they had detected microwave radiations coming from all around the sky. In 1965, Robert Dicke, a physicist working nearby at Princeton University, had learned of the measurements of radiation, about 3 degrees Kelvin, correctly interpreted it as the radiation from the Big Bang. Dicke had independently recognized the prediction of Alpher and Herman. It is said that by 1965, for all intents and purposes, the debate between the Big Bang theory and the steady-state theory was over, the Big Bang theory won. The discovery of the cosmic microwave background radiation. In 1927, Georges Lemaitre forwarded his theory of an expanding universe, later called the Big Bang theory. In 1948, George Gamow argued that the Big Bang universe would be at first dominated by radiation. Ralph Alpher and Robert Herman predicted that a remnant of the radiation would remain, a cosmic background radiation permeating all space. In 1963, Arno Penzias and Robert Wilson, while studying the sky's microwave noise, realized that they had detected microwave radiations coming from all around the sky. In 1965, Robert Dicke, a physicist working nearby at Princeton University, had learned of the measurements of radiation, about 3 degrees Kelvin, correctly interpreted it as the radiation from the Big Bang. Dicke had independently recognized the prediction of Alpher and Herman. The temperature of the universe was measured to be of a constant temperature of about 3 degrees Kelvin. Earlier, there was a question of the abundance of hydrogen and helium in the universe. It was observed that hydrogen comprised 73%, helium comprised 25%, and the rest of the elements comprised of just 2% of the universe. In 1946, George Gamow pondered the early stage of the expanding universe as a superhot stew of particles and began to calculate the amounts of various chemical elements that might have been created under such conditions. In the expansion and cooling of a universe from the early infinite density and temperature, the state of matter would have been protons, neutrons, and electrons merging in the ocean of high-energy radiation. He thought that the elements could be built up as an atom capturing neutrons one by one. Gamow succeeded in explaining the cosmic abundances of hydrogen and helium but failed to get a sensible answer for the creations of higher elements above helium. In the earlier time, the Big Bang theory have a hard time explaining how the higher elements were created. Currently, it has adopted the idea of the creation of the higher elements from the supernova. One of the observations of the universe is the observed structure called filaments. In 1979, Alan Guth, an American particle physicist, proposed a theory that an astonishing rate of inflation could have taken place in the first moment of the universe's evolution, then it slowed down. In 2012, he was awarded the Breakthrough Prize in Fundamental Physics for the invention of inflationary cosmology, and for contributions to the theory for the generation of cosmological density fluctuations arising from quantum fluctuations. Guth, along with Alexei Starobinsky and Andrei Linda, won the 2014 Kavli Prize for pioneering the theory of cosmic inflation.
Please give proper credit to the author for discussion of his ideas and theories. Thank you.